The true hallmark of any location is the people, those who choose to call it home. The Lehigh Valley is the land of makers and dreamers. Hard work is our heritage, and it's that heritage that fuels us. Our traditions unite us. Our legacy is determination. Our future will be built on the principles of creativity and perseverance. Because when others said we couldn't, we did. Some may think of us as underdogs, yeah? Well, never underestimate the underdog. Lehigh Valley has been and always will be home to those with great vision. We know the value of an honest day's work. We practically wrote the book on it. Out of the embers from the hands that forged a nation come those that are crafting the future. Now, if you'll excuse us, we've got work to do.
Welcome to the National Museum of Industrial History's Meet the Manufacturing series. I'm Karen Mossinger, President and CEO of NMIH. Here at the museum, we seek to explore not only the past, but also the present and future of industry in America. The Lehigh Valley, with its rich history of industrial innovation, is home to more than 15,000 businesses contributing to a diverse manufacturing base. Join us monthly for an inside look at Monterey manufacturing with representatives from local companies and help us celebrate the people, machines, and ideas that transform our daily lives. Meet the Manufacturer is made possible through the generous support of our premier sponsor, Lehigh Valley Industrial Parks, and also our series sponsor, Lehigh Valley Economic Development Corporation. And with your support, you can help us to inspire this and future generations of inventors and innovators by texting the word industry to 44321. You'll receive a secure link to make your donation. Or you can visit our website at nmih.org. We look forward to seeing you at the museum soon. Enjoy the program. Thank you.
Andrea Zaya, Curator at the National Museum of Industrial History. Welcome to the latest installment of NMIH's Meet the Manufacturer series. Joining me as a co-host tonight is Scott Unger, Executive Director of the Allentown Economic Development Corporation. Scott is a passionate advocate of urban manufacturing and entrepreneurship who brings 20 years of land development and nonprofit leadership to his role at AEDC. Since 2008, he has guided the organization in revitalizing Allentown's economy through brick and mortar projects and the Bridgeworks Enterprises Business Incubation Program. And our special guest for tonight is Andrew Schevets, a mechanical engineer by vocation and an entrepreneur by profession. He has a serious passion for creating and is currently president at Amorphic Tech Ltd., bringing ideas, machines, and industrial equipment into reality. Through Amorphic Tech, he has delivered products all over the globe to several Fortune 500 end users. So welcome to Scott and Andrew.
Thanks, Andrea. Happy to be here.
Yeah, thanks so much for having us.
Well, Andrew, why don't we start with finding a little bit about yourself. Tell us about your career path. How did you get started with being a mechanical engineer?
So I've been interested in making from a very young age. The cliche bit about taking things apart and then eventually graduating to motorized bicycles and cars and drafting and the like before I went to University of Pittsburgh, where I majored in mechanical engineering. And I got involved in a Society of Automotive Engineers program that really brought it together, the bit of physically making a component, not just designing it, but the impact and implications your design has on how you will physically produce and make a physical embodiment of this part. And that just did it for me. And I really thoroughly enjoy mechanical engineering and making. Before that, I worked for a major pump and fluids controls manufacturer in which I got exposed to some really impressive big machinery and fluid dynamic problems, and most importantly, the water industry. And that really sparked my interest. And, you know, those bits and pieces drove me to create Amorphic Tech and leads us to where we are today.
And as part of that, did you have any mentors or anyone in your family or friends who helped you launch this career path?
In terms of mentorship, my parents have just been tremendously supporting. When I didn't have any resources, my dad provided the first loan to really get things moving here. You know, later down the road, I borrowed money from my mom to get the first old CNC machine here. And their tireless support has, you know, helped me emotionally, physically, spiritually, and definitely made this whole thing possible. On a professional side, I had a particular mentor, Tim Watchering, who had guided me through my professional career, but then supported us as we came to approach these very challenging problems that nobody solved before, and doing something new. There's no map, there's no road guide, and so that was tremendously valuable. You know, there was another gentleman, Dr. Arup Sengupta from Lehigh University, who was instrumental in giving us a platform to spread our wings and help us, guide us to having a global perspective and, you know, really get us rolling with the government programs, which we've ultimately succeeded with and are currently continuing to work on.
It's fascinating. Andrew, tell us more about Amorphic Tech and how it was founded.
So the business was founded in December of 2013. It was just myself at my house. We had no equipment. I had an idea, and you know, I believe a year or so passed when I reached out to Allentown Economic Development for space. They put me on a month-to-month lease, which was perfect, to take this idea which I had, which was an energy recovery device to reduce the cost of fresh water. We built an initial prototype in AEDC space there, and we got some fantastic results. We were 20% more efficient than conventional technology, but we did not yet have a commercializable product. So we shifted gears to a services-oriented business in which we build up our manufacturing capabilities and prowess and expertise, which enabled us to ultimately continue this development and have our arms completely around the manufacturing and creating of this unit, which ultimately drove us to be able to innovate in ways where if we were paying outside contractors to do this, you know, the results would have been less than.
Well, Andrew, you're in our Bridgeworks Enterprise Center here in your manufacturing suite, as you described, and you're also from the Lehigh Valley originally. Were there any other factors that had you choose this location or Allentown?
Absolutely. You know, first and foremost, family is very important to me, and this is home. And so that was where, when I started looking around, you know, regionally located, I wanted to be. But as I got older, I began to thoroughly appreciate the rich industrial history and manufacturing history of our region from Allentown, Bethlehem, and Easton. And I became exposed to all these bits and pieces of heritage that I find tremendously impressive and inspiring. You know, I really love the concept of doing new age manufacturing of the most modern type in the skeleton of the old, and using it in a way that you can allow it to inspire you and take what's already come and use it to create something new.
By the skeleton of the old, I assume you mean the Mack Trucks Plant 4A, which we're in right now. So tell us a little bit about your customers.
So our customers are spanning from local organizations to billion-dollar publicly traded organizations to the federal government. And we perform a wide variety of work for them. We have regular day-to-day production work that we do that involves producing some of our own products, which will go to, say, the power generation industry, or developing R&D test loops, which we are taking a concept, designing, speccing all the components, and then physically manufacturing and commissioning a large-scale fluid test system. We have some clients who are very close with us here in the building, in which we're creating cryogenic components for highly precise cryogenic systems, such as ones that might be used in Microsoft's quantum computer. And so these are all things that we're excited about. And over time, we've modernized our capabilities and have become experts in our capabilities, which enable us to take things that were done the way they were and improve upon them. We still do a lot of work in the rotating machinery industry, and we find that these new manufacturing techniques can be utilized to not just our own benefit and innovation, but to our customers' benefits when we can take these techniques and use them to allow us to make something higher quality, better, faster, than it was ever before.
We often see your four-legged friend with you here in the Bridgeworks Enterprise Center. Who else is on your team?
Absolutely. So we have 3 of us who are here every day full-time in the shop. 2 of them working in the prototype technician and CNC machinist. Leading our operations, we have Thomas Martorelli, who is expert prototype technician and extremely skilled in programming and controlling all the fun equipment we have. Outside of that, we have Dr. Michael German, who supports our business development and grant writing efforts. And then we also have part-time support in the form of admin and accounting.
So in addition, you already explained a little bit about how your company works and your customers, but is there anything else that makes Amorphic Tech unique?
Yeah, absolutely. The technology that we've been developing, we see as game-changing. And it will enable freshwater producers to reduce their energy costs 20 to 40%. And for me, that is super exciting because water is something that I and everybody should care about. Everybody deserves access to fresh water. As I mentioned, we're able to take our in-house capabilities and use them to innovate in ways that, I wouldn't have even considered a couple days prior. We perform government-funded research on our technology development for the U.S. Bureau of Reclamation and also the Department of Energy. And in these research programs, we've developed really creative and fun ways to use things like 3D printing. We have these large, expensive CNC machines, which we innovate on regularly. But it's really fun to me when I use an old 3D printer and a $30 filament to 3D print things like a custom rubber seals, which will hold up to 1800 PSI, or we're using them to innovate on old manufacturing techniques and processes. The 3D printing is a really neat tool. And, it's something like this casing here in front of me, utilizing 3D printing to make that something in a way that 20 years ago we wouldn't have been able to do, especially with lower, cheaper technology, is just fascinating and really exciting to me.
You're talking about being inspired by historical processes and being able to incorporate that. Have you experienced that some of these older ways of doing things have really just remained tried and true?
No doubt. You need to understand the fundamentals. I'm a firm believer in walking before you run. Nobody is just an expert out of the gates. You need to learn. You need to make mistakes. You need to fail. And in my previous career position, I was exposed to some age-old techniques such as like lost wax casting. And areas where 3D printing might not be able to supersede that, you can implement it in ways that you're able to cast things that you couldn't cast before. We use 3D printing to cast new age epoxy composites and things. And in terms of utilizing that, it's just really fun for us to take an old technique, meld it with a new piece of technology, and then spit out something that was never created before. And then in terms of just standard manufacturing and machining, again, you need to understand the breadth and detail and use cases for basic tools and basic tooling before you move to the completely robotic automated equipment. And then you can really expand upon the use and do something that's impressive.
Mhm. And what is surprising you in how quickly some of the technology is changing in the fields that you serve?
I really love the premise of using a technology not just to achieve something and create a product that increases margin or makes something better. When I see innovations in the area of water purification, some of it is just very inspiring and surprising in ways where you're able to provide water to a community, which previously it was just not possible. There weren't energy resources, there wasn't electricity. And then, with the debut of higher efficiency solar cells and high efficiency, higher recovery water purification systems, all of a sudden you're able to give and provide something that was not possible before. And when it's something that is actually impactful to communities and real humans, that is just that much more enticing and entertaining and fun and exciting to work on.
So, a key part of what we like to do at the museum, a key part of our mission is really educating future generations and trying to inspire inventors and innovators in the field. So, you saw the value of STEM education when you were starting off on your career path. And what would you say is different today in manufacturing than, compared to, say, 10 years ago?
Um, you know, I love to see that there's been an almost democratizing effect of manufacturing as technology has trickled down, as computer 3D modeling and CAD CAM has become widely available and accessible to everybody. All of a sudden, the average person or child or student can have fun and make things and have a 3D printer and take something straight out of their brain and see what it looks like. And that is just a really neat thing. And for me, when I was in high school, I had a couple of teachers who let me color outside of the lines. I can think of two. I went to Emmaus High School, a local grad as well. I can think of two teachers in particular who allowed me to go beyond what the curriculum was offering and create something and physically build something. And those impacts are just tremendous on not just learning the theory of something, but putting it into action and again, trying something and failing and getting better at it through just sheer effort.
And I imagine that would be part of some advice that you would give to young people interested in pursuing a similar path, just, trying to experiment and going outside of, a comfort zone.
Absolutely. It's intimidating. Maybe your parents would give you a hard time, but, something like working on a car or a lawnmower, when you don't know, you need to start somewhere. Like I said, nobody's born an expert. And the older I get, the more I learn that life is a series of trying and making mistakes and failing and trying and trying. And being able to step back and see the trend of that moving forward. Absolutely. And, to those same folks, my advice would be to start doing it, right? Find a local makers club, find a library that has 3D printers or computer access if you're unable to do it. We live in an age now where, if you're really interested and you want to try making and creating something, there's avenues you can pursue. And that's the way where you will be able to make success and get better at it and do whatever the thing is that you're so excited about trying to do.
Just keep striving. Do you partner with any area colleges or universities or offer an internship program for young people?
In terms of internship program, that is something that we've done in the past, and we certainly plan to expand as we move forward. In terms of vocational education and also in terms of four-year degree programs, as we're continuing to grow, that's something that we would like to continue to foster. In terms of partnership with local universities, as I mentioned, We've done some really fun work with Lehigh in terms of, again, water purification and research grants with the Bureau of Reclamation there. And we just love partnering with particularly local top tier education. We love partnering particularly with top tier academic institutions, especially when they're local. We can use our local environment to help pick us up and pick up the region and the economic activity here.
Andrew, you've talked quite a bit about the innovation that you do at Amorphic Tech, and we've also talked about blending the new with the old. And it seems like about once a quarter you're bringing a giant new piece of machine equipment into your shop. What's the oldest piece of equipment that you've bought in terms of used?
Yeah, so we have two old manual lathes that are 1942 and 1945, and one of them actually has World War II wartime badges on it. And this piece I particularly love because it was the first piece that came out from University of Pittsburgh. It's the first piece that I ever used on an old lathe. And while they can't do everything, right, they're not automated or robotic, there is definitely a place for them in our shop. And we're able to hold tenths of a thousandth on some of this old machinery. And for us, that's really fun. Everything has mechanical feedback when you go to actuate them. And it just, it brings a smile to my face every time I'm using a piece of one of these equipment.
So what's next for Morphic Tech?
So right now we are feverishly working to make some success on our government grants. As mentioned, the Bureau of Reclamation, the Department of Energy, we've been working through. COVID has provided its challenges, but we are plowing ahead on those and making some really good success. And we're really looking forward to commercializing and turning on our factory for our energy recovery product. Foundationally, we're going to keep growing. We need to keep pushing our capabilities and enabling us to take what we've learned and take that next step. We're always looking to what we're doing in the future, and we're always trying to find people and a team to support that.
So we have some questions here that were submitted by our viewers. One of which has to do, can you tell us more about the types of machinery and technology that you have utilized at your facility?
Absolutely. So we have manual machining capabilities in the form of manual lathes, manual turning there. And then we have one manual mill that's manual CNC duo. And then we have a wide variety of secondary operation equipment, such as an automatic hydraulic saw, a vertical band saw, sanding, grinding, hand finishing tools, and the like. And then we have two CNC mills, one of them being a 5-axis machine, which we're able to perform completely modern manufacturing on. And then more recently, and then additionally, we have two CNC lathes, one of which was, while you're asking about the old equipment, one of which was made, a Japanese machine made in 1988. And this machine has needed the least amount of maintenance out of every single piece of equipment in the shop, which is just fascinating to me. We've recently built upon our turning capabilities and brought in a much larger CNC lathe that has an additional axis. So it has the X, Y, and Z axis, but it also has an additional chuck. So parts can be completed in a way that they are perfectly concentric and perpendicular. Then the part is passed off from one chuck to the other chuck, and then it is machined and finished on the back side. And this enables us to do things, again, better, faster, higher quality than ever before. And the goal of this machine was to enable our work with the Department of Energy to get to the next phase.
So we have some other questions here submitted sort of on that, on the manual or CNC machine question. Did you learn machining on manual or on CNC machines? And then do you think that students planning to go into the machining field should still learn on manual machining?
That's a no-brainer. as I said, you have to walk before you can run, and you need to understand the fundamentals. You will never be able to effectively program a piece of automated equipment if you don't understand all the nuts and bolts of what goes into that. So yeah, you have to learn the manual techniques and processes first, and you need to understand them. You need to understand the challenges and where you might fail. And then you'll take that and grow it and interpolate your skill set to use the automated equipment. And there is absolutely a place for someone to be learning the manual trade, no doubt.
We also have another question here. What is your favorite material to work with?
Oh, that's a good one. Part of the fun of making things is understanding the strengths and weaknesses of all the materials and how you need to treat them to get what you want in the end. I find, a standard like 300 series stainless is particularly fascinating because of their anti-corrosion capabilities, but also able to withstand high temperatures and minimize creep. And I understand they're really growing their application in, say, even aerospace field. And so for me, I think that's the most fascinating, when economical, and you can really stretch its capabilities to do something that wasn't previously done before.
Do you have any plans to get into 3D metal printing?
Absolutely. As I was chatting before, even the most basic 3D printing we've used to innovate in ways that have been tremendously beneficial to us in terms of prototyping, but do have long-term implications in terms of full product manufacturing capabilities. And metal 3D printing is right there with it. It was initially so expensive and unattainable, but now as time goes on, the process, people are innovating, the process cost is coming down, and it can be used in ways to rapidly prototype technologies. Our capabilities in-house, people use the word rapid prototyping loosely, but we embody it to the fullest extreme. We have an idea of something we want to test, we design it, we physically create it, and then we bring it across the hall to our test loop and test it. And 3D metal printing can only make that step faster and better.
And one of our members is interested in knowing if you work with outside suppliers locally, such as foundries or forges.
Absolutely. We work with a wide variety of local suppliers of raw materials and castings. Forgings, we don't do so many of, but I imagine a time will arise when we need to do some production work on forgings. Absolutely. In the field of rotating machinery, which we do a lot of work in, those items are all used pretty widely.
And you may have touched on this when you were referring to some of the older machines that you have at the shop. What is the oldest machine or system that you've ever worked on?
Oldest. Some of those lathes that I mentioned are 1942. That is pretty old. We've supported some miscellaneous pieces of equipment. I'm trying to think if any of them were much older than World War II era. I don't think so. I'm going to say 1942 there.
At the museum, we actually have an Effie Reed lathe from the 1880s. So we invite you to come over and use that. It is set up for demonstration purposes. So we hope you can come and use that at the museum.
Fantastic. I would love to, and I love the Industrial History Museum, going through and seeing, a piece of machinery in production. You can't keep it as it should look. And I love to go to the museum and see the intricate and complex decor and the painting looking as it rolled off the factory line. It warms my heart, and again, makes me appreciate the industrial history of the United States and also our local region here.
Yeah, exactly. We are in a very special area. We have another question that's come in. What does the name Amorphic mean?
Okay. So amorphic, being shapeless and formless, such as water. And so that idea came about because new 3D modeling and manufacturing capabilities enable you to create things that were previously not possible. So you'll have some set of functional requirements, and previously you had to conform to making this square or these really uniform shapes. But now you can create something that is abstract, almost artistic, at the goal of just complete functional optimization. And so amorphic being that you can take that idea of being shapeless and formless like water and use it to enable your products and your technology to take form in a way that previously wasn't possible.
All right. Well, we thank you for being with us here tonight, Scott and Andrew. And on behalf of the National Museum of Industrial History, thank everybody for joining us. It has been an inspiring conversation to learn more about what you are doing at Amorphic Tech, and it's going to be exciting to see what the future holds. Thank you to our premier sponsor, Lehigh Valley Industrial Park, and series sponsor, Lehigh Valley Economic Development Corporation. And your contributions make programs like these possible. So to donate to the National Museum of Industrial History, text INDUSTRY to 44321 or visit nmih.org/donate. Thank you all for joining us. We hope you have a wonderful rest of your evening and that we see you next time for Meet the Manufacturer.
Thanks so much for having us.
Great, thank you.
Morphic Tech is a vertically integrated technical solutions company who brings water technologies and industrial machinery to life. Their state-of-the-art design and analysis capabilities, coupled with CAM and multi-axis manufacturing equipment, enables the fastest route from concept to functional reality. We create and innovate.